What happens when your GPU-dependent pod lands on a CPU-only node? It fails. That's exactly the problem node selectors solve. A node selector is Kubernetes' way of constraining which nodes a pod can run on. Think of it as a filter. You label your nodes with key value pairs like disk type equals SSD or hardware equals GPU. Then in your pod spec, you define a node selector that says I only want to run on nodes with these specific labels. Kubernetes compares the pod's requirements to each node's labels during scheduling. If a node has all the requested labels, it's a candidate. If not, the pod won't land there. This label matching system is simple but powerful for basic scheduling needs. When do you use node selectors? Classic examples include directing machine learning workloads to GPU nodes, ensuring databases run on nodes with fast SSD storage, placing workloads in specific compliance zones for regulatory requirements, or reserving high memory nodes for data processing jobs. Anytime you need hardware-specific or location-specific pod placement, node selectors are your first tool. You define node selectors directly in the pod spec under the node selector field, or in deployment templates if you're using deployments. The syntax is straightforward. It's a map of label keys to values. For more complex scheduling like preferred nodes instead of required nodes, or rules based on multiple conditions, you'd step up to node affinity, which offers greater flexibility. But for most basic use cases, node selectors get the job done with minimal configuration. Node selectors let you control pod placement by matching node labels. Simple, effective, and essential for hardware-aware scheduling. Keep practicing, and you'll nail this in your next interview. Ready to practice for your next interview? Interview Mentor lets you answer real questions just like this one. After each answer, you get a detailed grade and personalized tips to improve. Watch your scores climb as you keep practicing.